Hi guys, welcome to the Pepcoding. In this video, we are going to solve split array largest sum. So here in this question, we have given an array with non-negative integers and an integer m, which shows that we need to split this array in m parts such that all the array in m parts are non-empty continuous subarrays. And after splitting them, we need to return the minimized largest sum among these m subarrays. So let's see this question by example. Let's say I have 7 to 5, 10 and 8. M is equal to 2. We need to split it in two parts. So for splitting them, there can be multiple ways. For like this, we can add in subarrays from 7 and the second subarray from 2 to 8. So this will be 7 and this will be 25. Now we can also add 7 to in the second subarray 5, 10 and 8. So for first subarray the sum will be 9. For second subarray the sum will be 23. We can also add 7 to 5 and then 5, 10. So this is the another way. This will be 14 in the first subarray. The sum of second subarray is 18. In the fourth one, here we can add 7 to 5 and 10, and in the second subarray it will be 8. So this will be 24 and 8. So these are the multiple ways of splitting this array. Now we have these subarrays, these all the arrays where we have the maximum sum here is 25. In this the maximum sum is 23. In this the maximum sum is 18. In this the maximum sum is 24. Now we need to return the minimized largest sum. So what is the minimized largest sum? So we have multiple choice of splitting this array in m parts. So whatever the array where we get the smallest sum among these. For example, we have here 25, 23, 18 and 24. So the smallest one in these will be the answer. We need to return this value. This is the 18 minimize largest sum. So our answer is 18. Here we are getting 18. So what will be the approach? Let's see. This is really a very similar question of allocation of minimum pages for n students. So if you want to understand this question more clear, first watch that video, then come here. Now I am going to use this. I am going to use another example. Here we have 7 to 5, 10 and 8. Now m is equal to 2. So we are going to use binary search where our low and high, we are going to use these values. So the low value will be if we have 5 elements and we need to split them in 5 parts. So what will be the answer of minimized largest sum? So the minimized largest sum will be 10. Here we can see the largest sum is 10. So the value of low is start from 10 in this example. Now for highest, if we want to split them in 1, this means we need to add these all and the answer will be 32. 7 plus 2 plus 5 plus 10 plus 8, that is 32. Now using these values we will find the mid. Mid will be 10 plus 32, that is 21. This mid will show a value which is expected sum of all subarrays we are splitting in parts. So let's see how will we use this. Now we will check, is it possible to split them in m parts with range 21. This 21 shows that the subarray sum should be in the range of 21. Now SA will be start from 1. We are going to use the first subarray. So first subarray is going to use the elements adding 7. This is the first element, and the second element. Here we need to compare these values. 7 is smaller than 21. Now we are going to add second element. 7 plus 2 is 9. 9 is less than 21. Yes. Now we are going to add 5. 7 plus 2 plus 5, that is 14. 14 is less than or equal to 21. Yes, it is. We are going to add the next value, that is 10. Here the sum is 24, which exceeds the expected sum. This means we need to add this 10 in a next subarray. So we will increase the value of subarray by 1. This means we are going to add the next element in second subarray. So it will start from 10. Now 10 is smaller than 21. Yes, it is. We will add the second element, the next element, that is 8. This makes it 18. 18 is less than or equal to 21. Yes, it is. So we have used all the elements and we have subarray. First subarray have 7 to 5. Second subarray have 10 and 8. Where the sum of these subarrays are lying between 21, from 1 to 21. This means our answer can be 21. Now, is this 21 a right answer? There can be possibility that if we take a less value than 21, it can be possible that we can part them into this array in two parts, and the value will be less than 21 for minimize largest sum. Let's see how. So we have 21. Now we want the smaller value. There can be the possibility from ranging 10 to 32. There can be possibility of 10 to 21. So 21 is the answer. So we are going to change the range from low to high. High will be mid minus 1, that is 20. Now again we will find the mid. Now find the mid. Mid is 10 plus 20 divided by 2, that is 15. So this time 15 is the expected value. 15 is the expected value. SA is 1, that is subarray count. Now this sum, we are going to add the element. This is 7. 7 is less than 15. Plus 2, that is 9, less than or equal to 15. Plus 5, that is less than or equal to 15. Then plus 10. This means we need the second subarray because it exceeds the sum. We want the expected sum, that is 15. So we are going to add this 10 in second subarray. 10 will be in the second subarray. Now we have 10. Now we are adding the next value, that is 8. 8 is also less than 15. 10 is less than 15, but 10 plus 8, that is 18, is not less than 15. This means we need another array, another subarray. So we will increase the subarray by 1, and this 8 will go to the third subarray. Subarray third. Here it will save 8. But here we have given m, that is splitting the arrays in two parts, and we are splitting in 3. So this range is not enough. So we need a larger value than 15. So we will increase this time. Earlier we were increasing. We are changing the high value from mid minus 1 when we get the answer. Now we need another subarray. This means our expected sum is less than the answer. So we need to change our low to mid plus 1, that is 16. Now again find the mid. Now mid is 18. 16 plus 20 divided by 2, that is 18. Subarray count start from 1. Now adding the element in the first subarray. Adding 7 less than is equal to 18. Yes. Adding 2 less than is equal to 18. Yes, it is 9. And now next element is 5. It makes 14 less than is equal to 18. Now we are adding 10. This makes 24, which is greater than 18. This means we need the second subarray. So for second subarray, it will start from 10, and this will go to the second subarray. Now 10 is smaller than 18. Yes, it is. Add this next element, that is 8. 18 is smaller than equal to 18. This means it is true. Now here we can see all the elements are used and we have the sub-arrays, that is 2. This means 18 is the answer. Now we will update the 21 by 18. Now we get the 18, but there can be possibility that the answer is lie less than 18. So we are at 18. Now we will update. When we were finding when we got the answer, we were changing the value of 5, mid minus 1, that is 18 minus 1, that is 17. Now again find the mid. Now we are going to find the mid. Mid is 16. This means we have expected range 16 starting from first subarray. 7 plus 2, that is 9. First subarray, 7 is less than 16, yes. 7 plus 2 less than 16, yes. 7 plus 5 less than 16, yes. 7 plus 10. 7 plus 2 plus 5 plus 10, that is 14 plus 10, 24 is less than equal to 16. No, it is not true. This means we need the second subarray. For second subarray, it will increase the subarray count by 1. Now we will add 10 in the second subarray. Now second subarray is 10 smaller than 16, yes. Plus 8, 18. 18 is larger than 16. This means we need another subarray. We will increase the subarray count. This means this 8 will go to the third subarray. We have the subarray count, that is 2. So this also makes the range which is low. So we need to update the low by mid plus 1, that is 17. Now again we will find the mid. Now we'll find the mid. Mid is 17. Now 17 we are again starting SA by 1. Add 7 less than, then 2 less than 17, then 5, it is also less than 17. Now we are going to add 10 in the sum. Here we can see it exceeds the value. This means this 10 will become in the next subarray. So we will increase the subarray count and this will start from 10. Now we are adding 8. 10 is smaller than 17. Now we are adding 8. 18. 18 is smaller than 17. No. So we need another subarray. Subarray count will increase and this 8 will go to the third subarray. Third subarray. Now this means the range is still not good. We need to increase the range. So for increasing the range from low will increase by mid plus 1, that is 18. Here the condition of binary such that low is less than equal to high is false. So loop will break and we will get the answer as 18. So this is the approach. Let's code this. Now first we need the low. So for finding the low we need the maximum value. Maximum value start from 0. For high we need the sum of the all the elements. So sum will start from 0. We need to find the sum. For int I equal to 0, I is less than array dot length I plus plus. Now for max equal to math dot max and array of I. Whatever will be the maximum value, max will be updated by that value. Now sum will be sum plus equal to array at I. Now here int low is equal to maximum and high will be the sum. Here there is one more case where let's say we have 5 elements and we need to split them in 5, as I have already tell 7, 2, 5, 10 and 8. We have 5 elements and we need to split it in 5. So if we split them, they will be split like this. So the maximum value among these will be the answer. So maximum value is 10. We will return the 10. So for this condition, let's write this condition here. If m is equal to array dot length, this means we need to return the maximum value. This will be the answer. As we need to find, we are going to use binary search for finding the answer. Low is less than high. Now we need the mid. Mid will be low plus high divided by 2. This is the mid. Now we will check, is it possible? Is possible to split that array in range of mid in m parts. If this is true, this means we need to update our answer by mid, and we will go to check the other answer. So high will be updated by mid minus 1. If it is not possible, this means our range is not in range. Our answer is not in range. This means we need to update our range from low. Low will be mid plus 1. Now we just need to write this is possible. Before that, we need to write this answer here. I am going to declare this answer is equal to 0, and we will return the answer. Now let's write the is possible function. Public public static boolean is possible. We have the array, we have arrange mid, we have m parts. Now first we need a subarray. Subarray will start from 1. Now we need the sum start from 0. Now what we need is, we need to traverse our array from 0 to array dot length I plus plus. Here we need to add all the element in the sum. If there is a case when sum is greater than mid, this means we need another subarray. So we will increase the subarray count by 1, and sum will be updated by array at I. This means we need to start from array at I now. Now for returning the value, we need to return true or false. Is it possible or not? So if our SA, that is number of subarrays, is less than or equal to m, we want to split. This means it is possible. So we will return this. This will return true or false. If it is possible, this will work and update the answer. So let's run this code. So it is accepting. Let's submit this. So it accepted all the test cases. So hope you like the video. Please share the video and subscribe the channel. Thank you.